Welcome to Arraylist methods. In this lecture, we'll be understanding the different methods that we can use that are present in the Arraylist class, and then after that, we'll be seeing how we can apply them in a program, and we'll be using the Dr. Java programming environment for that. So let's start off by understanding some of the different methods that we'll be using today. And the first method we'll be using is the size method. And the size method is a simple method. It simply returns an integer, and this integer represents the size of the list, or basically how many elements the array list contains. And it's very similar to a method present with arrays, and that is array name.length. And basically this length method can tell you how many elements are present in an array. So similarly for array lists, the size method is present. The next method we'll be looking at is the remove method, and the remove method returns e, and e represents an object. So it returns e, or an element, which is an object, and it basically takes in an integer as its parameter, and this integer represents an index. So whatever the index is indicated as, it removes the object or element at that specific index. So let's say if I were to say let's say arraylist name dot remove 2. So then what it would do is it would find the object or element located at index 2. It would return that object and remove that object. And what would happen is that if that object was removed, then the object or element originally at the third index will be moved to the second index, and all the indexes will be updated of all of the elements based on a removal. And the same thing happens for an addition as well. So basically, it returns and it removes the object at whatever index is specified by whatever the argument or parameter is. Next, let's look at the add method. The add method takes in an element or an object, and it basically returns a Boolean value. It always returns true just to signify that that object has successfully been added to the array list. And this by default adds the object to the end of the array list. So if you were to have a 5-element array list and you were to use this add method, whatever object you were adding as a parameter would be added on as the 6th element in this array list. So that's exactly how it would work. Now there's often a time when instead of inserting an element at the end of an array list, you want to insert it in the middle or somewhere like that. So that's where you can use another add method, but this add method takes in 2 arguments, and that is the int index and e object. So it takes in an object, and in this case you have to specify what index you would like this object to be inserted in, and it does not return any type. So basically, as you can probably tell, it inserts the element at the indicated index. So if I were to say add 2 comma object, whatever object, then it would insert that object or element at whatever index you would like, and then everything after, all the indexes after, or all the elements after the inserted element will have their index increased by 1, so that order is maintained. And that's what makes an array list really useful. You can modify, you can remove, you can add, and do things like that using different methods, and it does not cause any errors because you can easily change the size of an array list. And that's really what makes an array list so useful. And the last 2 methods we'll be taking a look at are the get method. And the get method basically returns the element at the indicated index. So you may remember when we want to access an element from an array, we go array name, and then in brackets we put like 2 or whatever index we want. So in this case we have the get method, and what this does is it returns an element at the indicated index. So let's say we have an array list named x, so we go x.get 1. So what this will do is this will return whatever element or object is present in in index 1 of the specific array list. And then the last method we'll be taking a look at is the set method. The set method takes in an index and an integer that represents the index and an element that represents an object. So it replaces the object. It replaces the element at the indicated index with the object given as a parameter. So basically what it means is that let's say that I go x, which is an array list, x dot set 2 comma object. So basically what this is doing is whatever is existing at index 2, whatever different element or object is existing currently at index 2 will be replaced by whatever is indicated as a parameter. So that's what, if you want to replace something, this is the method to use. So now this seems kind of vague, so we're going to dive right in and we're going to look at some examples of this in the Dr. Java programming environment to get a better understanding of how everything works. So let's move there. So here we are at Dr. Java, and I already have the program ready, so we'll be walking through it step by step to get a better understanding of it. So let's start off by identifying what file this is. This is ArraylistMethods.java, and the first thing that you should notice is that I have an import statement right over here, because remember, the array list, in order to use an array list, you need to import the array list class. Otherwise, the program will not function if you're using an array list. Next, I've declared the class, which is public class ArrayList methods. Then after that, I've declared the main method, public static void main. And after that, I'll make my first ArrayList declaration. And what I'm doing over here is I'm saying ArrayList integer x equals new ArrayList integer. And what this is doing is this is creating an array list named x, and all of its elements are of the integer object type. So now that we have an empty array list, let's start adding some elements to it so that this array list x actually contains something. So we have x.add 5, x.add 21, x.add 34, x.add 454, x.add 12. So we've used the add method, and basically what we're doing is every time we use the add method, we're just inserting an element or whatever indicated element to the end of the array list. So we say x.add 5, and 5 is added to the end of the array list. Then we add 21, so 21 is added to the end, behind 5. It's added at the end. Then we add 34, which is after 21. Then we add 454, which is after 34. And we add 12, which is after 454. And as you can see over here with the comment, we know how this array list looks, and we know that its size is 5. So now if I were to ask the computer to, let's say, print out something like system.out.println x.get2, and what this will simply do is this will tell the computer to get the element or return the element that is at the index 2 of this array list x. So in this case, what's at index 2 is 5. 5 is at index 0. 21 is at index 1, and 34 is at index 2. So this specific statement should return 34, and 34 should get printed out. Next, we'll be going system.out.println, and we'll basically be getting the size of this specific array list. So x.size, and this returns an integer, which tells us what the size of the array list is. So x.size will return 5 because there's 5 elements: 1, 2, 3, 4, and 5. So this should return 5. So if we were to print right now, if we were to run this program, this would print out 34 because that's at index 2, and this would print out 5 because that's the size of this array. So let me just put some comments right over here so that we can focus on the important part, which is these first few statements, and then after that we'll be taking a look at the rest. So let's just run these two statements right over here, and we should have 34 and 5 printed out. So let me compile. And as you can see, we got an error because I have forgotten to end this comment. So what I'm going to do right over here is I'm going to end the comment right over here. So there we go. Let's compile. And now the compile is completed. So that teaches you, remember, to when you start a multi-line comment, make sure that you end it. But now the important thing. So now let's run this program and see what happens. So as you can see, we run and we get, let me move this right up, 34 and 5. So remember, x.get2 is the second element at index 2, which is 34, and its size is 5. Now let's move forward and take a look at some more different code. So now we have x.set2 to 64. And what this is doing is, remember that the first argument or parameter is 2, and that basically specifies what index will be replaced, and then 64 is whatever you place the specific element with. So basically what we're doing is we're finding whatever element is located at index 2, and we are replacing it with the integer 64. And so now what happens is we know that 34 is at index 2. So now 34 has been replaced with 64. So now this is how the updated array list looks like, and its size is still 5 because even though 1 was removed, 1 was added in its place. So it was basically replaced. So now what we want to do is we basically want to, now we're going to print out what we're going to look at what xsystem.out.println x.get2 looks like. So remember we did this exact same statement before we used the set method, so we should expect a difference. So we'll get 34 and 5 first, but after that we should expect to get 64 because now the second element, element at index 2 is set to the value of 64. So let's compile and run and see what happens. So as you can see right over here, 64 is printed out. So after 34 it goes to 64, and suddenly there was a change in the value of the element at index 2 because we used the set method. So the set method can be used to replace different things. Now let's look at the add method, and the add method, basically there's two different add methods. The first add method we looked at right over here. These add methods add whatever the specified element is to automatically add them to the end of the array list. But this add method, which takes in two parameters, inserts the specified element into whatever index you'd like it to. So what we do here is we go x.add1, 82. So what this will do is at index 1 it will insert the 82 integer object element, and then everything after it'll basically insert that. So as you can see over here, this is the updated array list. Now before it used to be 5, 21, 64 and so on, but now it's 5, 82, 21, 64. So as you can see at index 1, 82 has been inserted, and everything from 21 onwards has moved 1 to the right. So that's basically what the insert method does, and it allows you to add in elements in the middle of an array list, and everything else is updated. All the different indexes are updated, and all the elements following the insertion are moved to the right. So now the size of this array is 6 because we've inserted something. So unlike the set method where we replace something, we've inserted something but we haven't removed anything. So the size will increase by 1. So now what we're going to do is we're going to print 0, 1, and 2, the elements as index 0, 1, and 2, and then we're going to print out the size. So we should expect to get a 6 for this statement. And for this, in printing out elements at 0, 1, and 2, we should expect to get 5, 82, and 21. And the simple reason we're doing this is to show how now the first three elements have been updated, because before they used to be 5, 21, and 64, but now they'll be 5, 82, and 21. So this is just to show how the add method will work. So let me do this right over here. Let's go right here. Okay, so now we're good over here, and now what we should expect is we already know that we're going to get 34, 5, and 64, and now we should focus on the last four numbers outputted. Let's compile, and let's run. And as you can see right over here, we have, what do we have printed out? We have, after 34, 5, and 64, we have 5, which is the first element, or index 0. We have 82, which is the element at index 1. We have 21, which is the element at index 2, and the size is 6. So as you can see, everything was successfully updated. Now let's take a look at the last method we're going to be taking a look at today, and that is the remove method. And what the remove method does is, we've looked at insertion, we've looked at replacement, and now we need to look at deletion, where something's deleted. And what we're going to be doing here is we're going to be removing whatever element is present at index 2, because that's what we've defined it, what we've given as an argument, which is 2. So as you can see, we go 5, 82, 64. Now if you recall over here at index 2 we had 21. So when we remove the element at index 2, which is 21, 21 is removed, and now suddenly 64 becomes the element at index 2. So everything is automatically updated. This is removed and everything is updated, and that's what the more updated thing looks like. And now because an element has been deleted, the size is now 6, and I'm going to be reprinting out the exact same set of statements we printed out over here to see how the change happens. Now we'll get 5, 82, and 64. Before we got 5, 82, and 21, and the size will now be 5 instead of 6 as it was before. So now this is the last thing we'll be running, so let's take a look and make sure it all works. So here we've compiled, and now let's run. And let me move this right up over here. So what's happened right over here is we got the 35, 5, and 64 from before. we got the 5, 82, 21, and 6. Now these were the last 4 outputs, which were the last more recent statements. So the element at index 0 is 5, the element at index 1 is 82, and the element at index 2 is 64, and the size is now 5 because an element has been deleted. So here we are, we've defined a basic array list. We've used the add method, we've used the get method, we have the size method, we've used the remove method, and different methods in order to insert, add, and delete different elements. And we've seen why array lists are so powerful, because we can make so many changes to array lists without any problems, and we can do things that we can't with arrays. So this has just been a basic look at the array list methods, and it's some way that you should be able to use array lists whenever you need to have flexible lists of objects.